Okay, here is the review packet for the quarter 2 cumulative test for Math 4. First, we're starting out with a little exercise in rewriting exponentials and logarithms. As a logarithm, this guy would, it helps if I turn my pen on. This guy would look like 7 for the base, 20y goes there, and the exponent goes to the right. So we do this. I guess you have to think of this as log base e, 2.33m. And so if that's the case, then it's going to be e to the 3m equals 2.3. Now, this guy, you would, I guess the best thing would be to distribute the 4 first. That would look like this. And then you would say 12 natural log u plus 4 natural log v. Now going back the other way, the 6 goes as the exponent of the a, and the 4 goes as the exponent of the b. Now, since they both have base 5, we can put those together as a to the 6th, b to the 4th. And they're being multiplied here. Now, solve each equation and round to 3 decimal places. So let's see now, we're going to start by dividing both sides by 2. That means we're going to have log base 6 of that equals 3. And then we're probably going to want to rewrite this out of a logarithm and into exponential, which 6 to the 3rd is 216. And then we're going to add 13 to both sides. So we get 229 equals x. Over here, we can take the log of both sides. Actually, let's just rewrite it as a logarithm. Log base e of 5, and the exponent goes over there. Log base e is basically natural log. Now, we can subtract the 2 over to the other side, and we would have natural log of 5 minus 2 equals x, and then we go to the calculator. And if we're going to round this to 3 decimal places, we get negative 0.391. It's 3905, and the 5 bounces the 0 up to a 1. So that is what our equation will look like. Now here we're just simply simplifying it down to a number that we can deal with. Now let's start with the square goes to the 4. Which 4 squared is 16. And since they're both base 2, the subtraction means that we're going to combine this as division, which that's 1/2. Now, if we're going to say log base 2 of 1/2, it probably would be helpful here to rewrite that as 2 to the negative 1. And those two, the log base 2 and the 2, cancel each other out, and our answer is -1. And remember, these two guys cancel out. Now, let's see what happens here. It would probably be helpful to recognize that 216, as I did a minute ago, is 6 cubed. And by the same token, log base 5 is 5 squared. Now, once again, we have a situation where these guys cancel and these guys cancel. So all we are left with is 3 minus 2 equals 1. Now we're getting into some of these formula problems where you will need to have those formulas handy. Here it goes something like this. Where n is the number of times a year you do it. Well, this is going to be 365. And then t is the number of years that you do it. Now, you want to find out if it's compounded daily, how long will it take to double? Well, your principal was 2,000, and you want to find out, so how long will it take to reach 4,000? Your rate is 9%. You're doing this 365 times a year. And then the only thing you really don't know is t. So we're first of all going to divide both sides by 2,000. That's going to give us 2 equals, and I'm going to take this and go ahead and figure out what that is as a decimal. 0.09 divided by 365. All right, so if I combine 1 plus 0.09 over 365, it's going to look like this. And I'm going to put the 2 over there because now I'm going to rewrite this in logarithm form. And that's going to be the base. And that's going to be the number there. And then 365t is going to go over there. Now, we had that change of base formula to where we could, if we have a log of this and log of that, we don't have the ability, most calculators do not have the ability to put that in quite like that. It won't let you drop down and put a base in there. So we have to say log of 2 over log of 1.000247. I've actually got the original decimal still in my calculator. And so I'm just going to use that log of 2 divided by log of answer. I still have the answer in my calculator. And that's going to give me something like this. And then I'm going to divide both sides by 365. That's going to give me about 7.7 for time. It's going to be about 7.7 years. Okay. Now we're playing the same game if it were continuous, which the formula is going to look a little different. And so doubling the money would be 4,000. We started with 2,000. Our rate was 0.09, and we need to figure out what is the time. So by the time we divide by 2,000 again, we're going to wind up with a 2 on the right side. And so if I rewrite this as a log, I'm going to go log E of 2 equals 0.09t. And that's basically natural log of 2. And so natural log of 2 is about 0.693. And by the time I divide both sides by 0.09, I wind up with 7.7. It would take about the same amount of time. And part of that is because the number 9, you were compounding it daily, which is so frequently that it is, I think the difference, the number 9 was actually 7.7025, and this one is 7.7016. There's that much of a difference, but you're only talking about $2,000. It wasn't a huge amount of money. Those differences would start showing up with a larger amount of money. All right, find the APY. Now, remember the rule for APY is 1 year, $1. So we're going to go back to the original formula, compounded monthly. And so we're going to plug in. Our principal is $1. Our rate is 0.105. We're doing this monthly. And our time is 1 year. So all we have to do is plug all of that in and simplify. And the calculator gives us 1.11002035. So that is going to mean that we are getting about 11.02%. Okay. All right, wild horses on Egbert Island. Now, this is where we're using the formula of basically PERT. That's the same formula, really. And, oh, wait a minute, this is doubling. This is doubling, that's right. We're going to go in a completely different direction because we're going to take the principal and we're going to double it. And the fact that it does it every 24 years, if I were to put a 24 in there where x was, that would be 2 to the first power, which means it would double once. And that's kind of what I want it to do. So the population was 413 at this point. And project the year when the population would reach 900. So that is what we have to solve. We have to solve for x there. So we're going to first of all divide by 413. We wound up with something like 2.1 0.179 is about equal to 2 to the x over 24. Now we're going to rewrite this as a logarithm. Log base 2, the exponent goes over there, and the 2.179 goes here. Now I've still got that decimal in my calculator, so I'm going to say log of answer divided by log of 2. And that's basically what we're going to do here, is we're going to set it up like that. And when we get a number there, we'll just multiply by 24. All right, so this log over log turns out to be 1.12 about. And then I'm going to multiply both sides by 24. And that's going to give me 26.97. You might as well say 27. Now, they said project the year. This is going to be 27 years into the future. So 2018 plus 27 is 2045. Okay. All right, U-232 has a half-life of 69 years. Now that formula ran something like this. Original mass times e raised to the negative RT, where R was equal to the natural log of 2 over the half-life. So if my half-life is 69, then R is going to be natural log of 2 over 69, which is, calculator, and it says 0.0100. Well, we'll just say 0.01, because that's accurate to 4 decimals. There's no real need to write the other 2 zeros. So let's see now. Our original mass was 150, and we want it to go down to 30. And we don't know how many years yet. That's the one missing variable we have to figure out. Well, first step is to divide by 150. 30 over 150 really reduces, matter of fact, let's keep this easy. That's 1/5, that's 0.2. And then we're going to rewrite this as a logarithm. And the exponent goes over here, and the 0.2 goes there. Well, log of e, you might as well say natural log. We're going to figure out the natural log of 0.2 and then divide it by negative 0.01. Okay, so natural log of 0.2 is negative 1.61 roughly. And then when you divide both sides by negative 0.01, you wind up with about 161. That is how many years it should take to drop down to 50 grams. Now we get to figure out the mass after 200 years. Now this is actually going in the other direction. We're going to, well, we already know that R is 0.01, and we know that our mass is 150, and we know that we're talking about 200 years. So all we have to do is put all of that into the calculator and see what it does. And we get 20.3. And that is the mass of the amount, so that would be 20.3 grams. All right, now given the equation of this guy, name the transformations that would create this guy. How did I turn from that into that? Well, first of all, I had to stretch it vertically by another 2. That's how the 2 became a 4. Now, how did the x plus 3 lose its parentheses? That's because the 3 disappeared. Now, when you think about it, x plus 3 in the parentheses does not mean it's moving to the right. It actually means it's moving to the left. So to undo that, I would have to move it back to the right. And then I didn't have a -1, but I do now, which means I'm going down 1 unit. All right. Now, I think I'm going to pause there, and we're going to pick up with the other 15 questions in the next video.